Alright, hi you guys. Today we'll be talking about parabolas. Okay, so some information needs to be known, so I'm going to point out some stuff right here. Okay, we have our parabola poorly drawn by me. And we have this point in here and we have this blue line back here. Okay, this blue line back here is called the directrix. Okay, and this point up here is called the focus. This is actually really kind of cool. Now there is a focal length. Okay, they also call it a focal width, so it just depends on where you're at. Okay, but the focal width is going to be this right here. And actually quite interesting, the focal length, since we'll be calling it for this time, is going to be the absolute value of 4p. So whatever 4p is, it's going to be the length of it. Okay. Alright, now some of you guys are probably wondering, what does this stuff all have to do with each other? Okay, well, I probably should move the directrix up a little bit because that focus is right there. Yep, there we go. Okay. Alright, the focus and the directrix. Now, here's a really cool fact. If I were to draw a line from the focus to the parabola, that line, if I were to draw it to connect to the directrix, those two lines would actually be the same length. So this is actually kind of a cool property of it. Okay. All right. Now here is your formula. Your formula sheet for the conic known as parabolas. Okay. Now probably in Algebra 1 you didn't expect parabolas to be this involved, and as a matter of fact, you probably remember most of this stuff. For example, this part right here looks very familiar. The A in front, not as much. You probably found it a different way, but today we'll be finding it a lot different way. Okay. Now, as you can see, there's little subtle differences between finding the focus, directrix, and axis of symmetry for each one. The vertex is going to be the same in both, so that's not an issue. Okay. And as a matter of fact, finding A, which is going to be 1 over 4p, okay, or if you wanted just p, it'd be 1 over 4a. Okay, those are going to be the same for both, so that works for both. However, it's these ones that are going to be different from these ones, so you have to be careful. So, like for example, if you're working with a vertical parabola, which is this, okay, all right, which is our typical. This is the typical one. This is the usual one. So typical one that you're used to. Okay, this one is the new one. Okay, the horizontal, it's the one that goes on its side. So you're going to have to pay very close attention to how the focus, the directrix, and the axis of symmetry work. And if you graph them all, they should line up. So let's go ahead and take a look at some. Okay, so here's an example of both of them. So for example, this one is the horizontal parabola, and as you can see, A is right there. Okay. Alright, and here's an example of the vertical parabola. Okay. Alright, now what I'm also going to do is I'm going to graph another line at the same time. And this is actually going to be the directrix. And what you can do is you can actually graph the point of the focus. So like for example, if we wanted to do the focus would be 1 over 4a. So we would go enter, and then we would just graph the point. 0, well, it would actually be, let me see, be h, comma, 1 divided by 4a. There we go. And voila, you actually have it there. And what you can do is you can actually work with it and you can see how it works. And as you can see, as I make a smaller, the focus gets further away, and so does the directrix. Okay, and as you can see, if I make it negative, once again, it's just like that. So if I zoom in quite a bit,
okay, I'm sorry. Thank you so
you can see some pretty cool stuff. I think I really like this, how this is all set up. Okay. Alright, so that point's going to be able to be moved around. Alright, now if we were doing the other one, let's do this one right here, we would need to click over to this. Okay, and what we could do is we could actually graph the point 1 divided by 4a comma k. Okay, so as we moved around A, you could actually see it move around as well. Okay. Alright, so the smaller A gets, what's happening is that my focus is getting further away. Okay. Alright, so that's some really cool stuff that you can actually work with right here. Alright. Now as you can see, there's a whole bunch of other conics I have on here, so I'm just going to leave it be. B's don't change anything about it. They actually will talk more about them a little bit later. Okay. Alright, but that is pretty much it for parabolas. Just working with them, we'll work on some example problems, but this is just looking at how the actual applications are of each one. There we go. Okay, but that's how the directrix and the focus actually work in their unique way. So let me do this. There we go. If we zoom out a little bit, you'll be able to see it a little bit smoother. Okay. Alright, so now here's the really cool thing that we can actually work with this. Okay. You can actually see what the focus does. As you can see, and this is actually some real-world application stuff. This is from interactivemathematics.com. As you can see, as these lines come down, when they hit this point and they reflect off of it, and this is actually really interesting how this works, is they will reflect to a focus point. Okay. Okay. As you can see, it's getting further and further away. Alright, and as you can see, no matter what happens, even though that this parabola is getting fatter and fatter or flatter and flatter, it's still bouncing to the focus. So this is the really cool thing about it. Okay, the focus and what it actually does. And this is what telescopes actually are used for. And this focus is where you will actually, when you look inside of a telescope, you're looking at a series of mirrors that go to the focal point. Okay? Right? And then because of that focal point, you can actually see all of the light that's coming in. So as you can see, even though it keeps getting flatter and flatter and it takes longer and longer for that light, and whenever you're dealing with physics and stuff or optics, you'll be using this as light. Okay? It keeps bouncing off and it keeps getting further and further, and it takes longer for it to actually go. Let's go all the way. Let's see if this resets. Oh, keeps going. Okay. Alright, so let's find the equation of parabola with the vertex as the origin and the focus at 0, 2. Okay, so here's the actual vertex. Okay, now if we look at our formula sheet, and that's located in the message boards for you guys, the focus, and if we think about this, is 0, 2. Okay, so that would be a vertical parabola. So this is vertical. How do I know? Okay, the reason why I know it's a vertical parabola is something's being done. If this is the vertex and then this is the actual focus, something's being done to the second point. Okay, I'm adding 2 to get from the vertex to the actual point. Okay. Alright, so now that I know that, the only thing being done to the second point in the focus isn't the horizontal parabola, it's the vertical parabola. Okay? Alright, so I know it's vertical. Okay? So I know that the form is going to be y equals a times x minus h squared plus k. Alright, and this should be a. My bad. Alright, so I know it's in that form. Okay, now I know the actual vertex is going to be 0, 0, so I put this in for 0, and I put 0 in for 0, or k, and so now I get y equals a times x squared. Okay, now I'm also going to use the formula at the bottom that a is 1 over 4p. Okay. Now, how do I find P? P is actually found in the focus formula. The focus formula is 0, comma P in this case. The reason why it's 0, comma P instead of H, comma K plus P is because if we add 0, 0, or to go from there, well, if the origin is at the vertex, the focus is just going to be 0, comma P. Okay, now if you notice the difference between the two is that it got a 2 and a P, so 2 equals P. Okay, so now I know that A is going to be 1 over 8. Okay, and I can replace this with y equals 1/8 x squared. And voila, I actually found the equation just by giving one piece of information. Okay, so now we're going to take a parabola equation and find the vertex, focus, and directrix of it. Okay, so what you're going to do is the amazing, the always wonderful, complete the square. So we're going minus 4x. Okay, so we're going to take half of 4, negative 4, which is -2, square it. Now, instead of adding it to both sides of the equation, okay, we're going to do it like this. We're going to actually keep it on the same side. Now, when you keep it on the same side, you're going to have to minus it at the same time. Okay, so the new stuff is this plus 4 and this minus 4, and that comes from completing the square. Okay, so y equals, now I'm going to factor that first part, and that's going to be x minus 2 squared plus 4. And voila, I have it in vertex form. So vertex form is really easy. But I'm also going to pay attention to the number in front, which is 1. And that's going to be important in finding all the other stuff. So vertex form, pretty easy. So the vertex of this is going to be 2, comma 4. Okay, now the focus is going to be a little bit harder. Okay, so I need to think about it. Okay, what kind of parabola is this? So I'm going to look at the y equals and the x squared, and this is going to be our traditional vertical. So our focus is going to be, if I look at the formula, it is 2, comma 4 plus p. Okay? Alright, so that's the focus. And then the directrix is going to be y equals 4 minus p. Okay, so if I find p, I can actually just plug those in. Alright, but if you notice, all I have is a. But there's a formula at the bottom that says p is equal to 1 divided by 4a. Okay? Alright, so in this case, our a is 1, so this just turns into 1/4, so our p is 1/4. So guess what? I'm all done. So this is going to be 2, comma 4.25. Okay? And this is going to be y equals 4 minus 1/4 is going to be 3.75. And voila, I found the directrix, the focus, and the vertex just by completing the square. Okay. Now, what you could also do is set up the equation and double check it just to make sure everything's correct. You could also set up the focus and the directrix to see if you're all set. Okay. All right, that is it for parabolas. I will talk to you later about more conics.